talking about calculations involving transformers. Basically, these are the main equations we use when dealing with calculation of transformer. Remember that power is defined as product of what? Current and voltage. That is what we refer to as what? Power. So, and we have two types of winding in transformer. The primary winding, based on the structure that we have described earlier in the previous video. We have the primary winding, then we have what? Secondary winding. Because there's current and voltage that are being generated at this side, automatically we are going to have power input. That is the power coming from the source, and we are going to have the power output. So basically, the input power or power input for a transformer is given by the formula IP Vp. The meaning of IP is what? The current that you have. The meaning of IP is same thing as the current that we have at the primary winding. It's same thing as what? Current that we have at the primary windings or the input side or the main side. And voltage is same thing as what? The primary voltage or the source voltage. Then we have output power is same thing as what? ISVS. That is current at the secondary and the voltage at the secondary. Also, we define efficiency of machine as what? The output power divided by input power multiplied by 100%. So if I should substitute the value of, this one into the output to, the input to the input part, and I substitute this output to what I'm having here, automatically we are going to have the efficiency of machine to be same thing as what? Of our transformer to be equals to ISVS divided by IPVP multiplied by 100%. And that is what you have in this place. Also, we have another part of the transformer, another part of the equation, which is what? VP over VS equals to IS over IP. Same thing as what? IS over IP multiplied by what? NP over NS. Now, how did I arrive at this particular one? How did I arrive at this particular equation? So everything is derived from this, as we are going to see from my explanation now. Remember, from the transformer equation, we said efficiency is same thing as what? The power output over what? Power input multiplied by 100%. That's what you call the efficiency, right? And we simply said this same thing as what? We'll have this one to be efficiency equals to what? ISVS over IPVP multiplied by 100%. So if I'm having ideal transformer, for ideal transformer, I'm going to have the efficiency of it to be equals to what? 100% for ideal transformer. Though that doesn't exist, but let us assume we have ideal transformer. So what I'm going to have in that case is going to be 100% at this side. 100% will be equals to ISVS over IPVP multiplied by 100%. Because I'm assuming this one can only possible when you have ideal transformer, like I said earlier. But if the transformer is not ideal, we cannot have the efficiency to be equals to 100%. So this one and this one, we cancel each other. I'm going to have 1 now to be equals to what? ISVS over IPVP. If this is over 1 and I cross multiply, what I'm going to have now is going to be my IPVP will be equals to ISVS. Now, if I rearrange this one and I want VP to come first, this one will come down, VS will come down here. I will divide this place by VS, and this one will come to the other side. I'm going to divide here by what? By IP. So from this now, my equation, if I rearrange this, my equation, if I rearrange what I just mentioned now, rearranging based on what I said now, I'm going to have my equation to be the same thing as what? VP over VS to be equals to what? IP equals to what? IS over IP. VP over VS equals to what? IS over IP. That's what I'm going to have. That is for the first part. Now, for the second part, which is the one that involves coil. For the second part, which is the one that involves a coil of wire. So, for us to get that one right, we have to go back to Faraday's laws of electromagnetic induction for us to prove that. And to prove that one, remember that according to Faraday's laws of electromagnetic induction, it said induced EMF is directly proportional to what number of turns of coil linking the circuit. So from this one now, I can have my E now to be equivalent to what? Kn. I'm assuming K is my constant here, though. So divide A by N, divide A by N. N and N will cancel each other. I can have E over N now to be constant. So I can have, if it is primary and secondary I'm using, that will be what? EP over NP will be equals to what? ES over NS. That's what I'm going to have it. So if I rearrange this one, I'm going to have my EP over ES to be equals to what? NP over NS. So from here, if you join everything together, remember EMF is the same thing as a potential difference if there's no any internal resistance, though we are less concerned with that. Under this topic generally, EMF and voltage and potential difference, two of them will be used interchangeably. So if this one, E is same thing as V, so I can still rewrite this equation. I can still rewrite this equation I'm having there as you are going to see now. So what I will be having is simply going to be what now? I'm going to have this equation to be equals to EP over, VP, VP over VS equals to NP over NS, and that is equivalent to IS over IP. So if you notice this now, V and N, they share the same pattern. PP is following each other. It's only the current part that is you are having S. So if you want to interchange too, you can still rearrange the equation such that you are going to have this one to be equivalent to VS over VP equals to what? NS over NP, and that is equivalent to the last one, which is going to be what now? Because I'm having SS now, P is going to come out. That's going to be IP over IS. So it's only the current parts that is having a different equation. So let's back to what we are having here now. So, and this is a summary of the equation once again on how to on transformer or calculated transformer. So let's look at the view question. Sorry, before going to the view question, one of the way you can use to differentiate between primary and secondary is that whenever they mention the term source or they call it main, so in that case, we'll revert to it as what? As our primary side, whether voltage at the primary, current at the primary, power at the primary. Why anything you are supplying to is to revert to as what? As the output, as you are to be seen after. So let's look at the first question that we're having. The first question we have says, the voltage and current in the primary coil of a transformer are 200 volt and 2 ampere respectively. If the transformer is used to light 10, 12 volt, 30 watt bulbs, calculate its efficiency. The first thing we are required to calculate in this question is efficiency. So let's list out the parameters given to us in this question. The first one, we are calculating efficiency. Efficiency is unknown, as you can see from here. And we said the voltage and current in the primary, it is clearly stated from the question that the voltage in the primary equals to 200 volts, and the current we have at the primary is what? 2 ampere. Now, if the transformer is used to light 10, 12 volt battery bulb and 30 watt bulb, so that shows that, remember what we are having in this place, the 30 watt you're having here is meant for power. That is power. And this is what you are supplying the current to. So as such, we consider this 30 watt as what? The power output in that case. We consider it to be our power output. So that shows that from here now, we have gotten the power output. And another point there is that how many bulbs am I having this time around? The question mentioned 10, 12 volts. So for a single bulb is 30 watt. That's why I mentioned 30 watts per bulb here. And the voltage I'm having here too, for a single bulb, I'm having what? 12 volts. So that shows that for 10 bulbs, I'm going to have 10 multiplied by 30 watts. So before going into that, or before we are going to utilize the number of bulbs that will make use of, remember the efficiency of machine from our previous equation, the same thing as what? The output power or power output divided by what? The input power, which is same thing as power input multiplied by 100%. So that shows that if I should substitute this one into my equation now, I'm going to have the power input. Remember, power input is the same thing as what? IPVP. So I can just substitute everything back to this equation like that. Efficiency equals to what? Power output divided by IPVP. And the reason why I'm using IPVP is that the power input is not given to me. Power input, same thing as power in the primary, is not given to me directly. But I can calculate it using the formula for power, which is what? Power equals to IP. So IV rather, power equals to IV. That's why I put this one here. And I'm using just power output here because the power output power output for the bulb is given to me directly. That's why I'm using the power output to be equals to 30 watts. Then from this, What is my power in the equation? That is 30 watt. I'm having 30 watt here. How many bulb am I lighting? That's going to be what? 10 bulb. So that's going to be 10 multiplied by 30 watt. That's going to be the total output I'm going to have. Divided by IP. Our IP is the same thing as 2 ampere. I'm having it to be 2 A. And we have our VP is the same thing as what? That is the voltage we have for the output. Power input rather. That's the same thing as 200 volts. Yeah. So simplifying this one, I'm going to have 30 times 10 divided by 2 times 200. That's going to give us 300 times 100% divided by 400, and that will give us 75% efficiency like that. The next question that we'll have, the second question now. A household supply with a what? A 240 volt AC main. The supply voltage, the main voltage, the primary voltage, I told us already that they are the same thing. And that's same thing as what? The primary voltage that we have in the circuit. To operate a doorbell rated at 8 volts. So what you are supplying to, the voltage that the transformer is regulating to is what? 8 volts. Then if the number of turns of coil in the primary coil is 900, calculate the number of turns you have in the secondary. So let's list out the parameter given to us. The primary voltage, which is same thing as the main, don't forget that, it's same thing as the main, it's same thing as 240 volt. Then we have the output, what you are supplying to. The rating of the device that you are using transformer to operate is what? 8 volts. And we have number of turns of coil in the primary to be equals to 900 volts. And we are required to number of turns that you have in the secondary coil. How do I solve this one? Remember the general transformer equation. In any question you are solving, just try and put everything down in order. Once you put everything down in order, then you can pick the one that you need. We have VP over VS equals to IS over IP equals to what? NP over NS. A quick reminder, I told us both V and N, they usually follow the same pattern. Primary, current is secondary. So this is the equation I will have. But merely looking at this equation, you will observe something there. And what will you observe? My question here just contains V and N. So because the question I'm solving here involves just V and N, I'm less concerned with current. You can easily eliminate the current part here. And what will be left with, if the current part is eliminated, is now going to be what? You have IS over IP still there. You eliminate it here as well. What is our VP in the question? The VP in the question is the same thing as 240. I'm having my 240 here. Then the VS is the same thing as 8 volts. I'm having 8 volts here. Number of turns of coil in the what in the primary, NP, is the same thing as 900. We are looking for number of turns we have in the secondary, and that is unknown, as you can see from this equation. So because you have eliminated IS over IP, then the next equation I'm going to be having is going to be 200 over 80 over 8 divided by 900 over NS. If you cross multiply in this place now, if you cross multiply here, you are going to have 240 NS equals to 900 times 8. And dividing both sides, divide here by 240 and divide also by what? By 240. This and this will cancel each other. I'm going to be left with 900 times 8 divided by 240. And that will give us 30 tons. The next question. A transformer with 5,500 tons in the primary. This one is well spelled out as well. In its primary is used between a 240 volt AC main, AC supply. Meaning the primary here told us the supply voltage of the main or primary are the same thing. And a 120 volt K2. So our output is what? 120 volt. Whether K2, whether refrigerator, whether anything, any gadget that you are using transformer to operate is considered to be the what? The secondary part. So this is a secondary voltage with same thing as VS. Calculate the number of turns you have in the secondary. You are looking for NS like the first previous question. So number of turns in primary is given to us as 900. Then we have number of turns we have in primary is given to us as what? 240 volts, as you can see. It's given to us at 240 volts. Then the next thing we have is what? We'll have the number of the voltage that we have in the secondary. Output voltage is same thing as 120 volt. We are looking for NS. So follow the same pattern. Remember the general transformer equation already. So from this one, what we are having next is going to be what? Remember I said IS, VS will be cancelled. Because in this question also, nothing like current is given to us. Nothing like current is given to us. So what I'm going to have is substitute all the parameters given to us. Our VP, the voltage that you have in the primary is same thing as what? 240 volt. We have it here. Voltage in secondary is 120. We have it here. We don't have anything about the current. They are going to be annihilated or cancelled. Then we have number of turns we have in the primary is 55,500 rather. That's what you have here. And NS equals to unknown. So from this, we have this part. So if you cross multiply in this place, we are going to have 240 NS equals to 55,500 multiplied by 120. Divide both sides by 240. Divide it also by what? By 240. 240 and 240 will cancel each other. So I'm having the next step here is going to be equivalent to 55,500 times 120 divided by 240. And that will give us 27,750 tons. And that is what you are required to calculate for this third question. The fourth question. A transformer has 100 tons in primary coil, 10 tons in what? In secondary coil. If 240 volt is applied to the primary, take note of that, is applied to the primary, calculate the voltage across the secondary. So you follow the same pattern. Number of ton in primary equals to 100, as you can see from the question. Number of ton in the voltage for the primary is mentioned in the question to be equals to 240 volt. Then we have the voltage in the secondary. That's what you're required to calculate. The number of tons in secondary is 10 tons, as you can see from the question. Is 10 tons, as you can see from the question. Then the next thing we have is what? State our equation out. Remember as well, this one is going to cancel each other. Substitute the value of Vp, that is 230 divided by Vs equals to 100 over 10. So from this, if you cross multiply here, remember 0 and 0 will cancel each other. I'm left with 10 over 1. So if you cross multiply in this place now, the next thing you are going to have is going to be 10 Vs equals to 240 volt. Divide both sides by 10, divide A by 10, divide it also by what? By 10. 10 and 10 will cancel each other. Then you are going to have this one to be equivalent to what? 240 divided by 10, which will give us 24 volts. This is what you have regarding the first question. The fifth question, this is a bit longer. The question gave us that a 90% efficient transformer is used to operate GHA fan rated 50 watt and 120 volts from a 240 AC supply. Calculate the ratio of number of tons in primary to that of the what? That of the secondary. So state out the parameters. Efficiency is given to us as 90%. Power output is given to us as 50 watt. And we'll have the voltage for the secondary, because this is what we are using the transformer to operate is 120 volt. And this is from the source is 240 volt. So from this place, we are required to calculate tons ratio. To calculate tons ratio, we are calculating NP, the said number of tons in primary to that of the secondary. That is NP over NS. And remember from our equation that we have stated earlier, NP over NS, same thing as what? VP over VS, because it is pairs of voltage that's given to us. Simplifying this one, you are going to have our final answer to be equivalent to 0 and 0. We cancel each other. 12 here, 1, 12 in 24. That's going to give us 2. So that should simply be 2:1, like that, 2:1. Then to calculate the efficiency, we are required to calculate current from the main, meaning we are calculating current in the primary, IP equals to unknown. So to solve that, just remember the formula for efficiency that we have stated earlier. Efficiency equals to what? Power output over power input multiplied by 100%. And because we are looking for current in the primary, I can just convert my power output here to be the same thing as what? IPVP. Then from there, we can substitute a value. Efficiency equals to 90%. Power output, same thing as 50 watt. IP is unknown. Then voltage in the primary equals to 240 volt. So simplifying this one by cross multiply, you're going to have 90, this over 1, 90 times IP times 24. 90 times IP times 240 will be equals to 50 times 100%. If you divide both sides by 90 times 240, you are going to have IP to be equivalent to 0.21 ampere. And that is